place, and I don't want to see it. Acha, let's do 14. Find the least value of a such that the function f given by question number 14. 14 कहाँ से 14 आसमान से. अच्छा, those who haven't attended the class, please look at those videos which I have uploaded. In that video, I have all the questions we have discussed. Okay. टाइम कम है, क्लास ज़्यादा लेना पड़ेगा, और क्लास ज़्यादा लेने के लिए क्लास ज़्यादा अटेंड करना पड़ेगा. ओके. You are not in. You are not informed, but you have a that WhatsApp group, right? What about your WhatsApp group? Why you are not? Oh, but you haven't had before. Before then, what you had? Before you, what you had? What app did you had before? You haven't had your number in WhatsApp. Acha, fine, I will add it now. But please do go through the video which I have done. So all the explanations are in there. Okay? Yeah, yeah, yeah. So today only I will. Yes, yes, yes. Okay. Today I will. Okay. Now look at here. So find the least value of a such that the function given by f. This one is the function is increasing on 1 to 2. Okay. So they are telling that we have to find the value of a. We have to find the value of this thing such that from the from 1 to 2 the function is increasing. Okay. So first thing, when the function is increasing, all I need to do is I need to find the slope of that thing. So let us find the slope. So what is slope? How to find slope? We'll do fx is equal to x square plus ax plus 1, differentiating with respect to x. So what do you get if I differentiate with respect to x? I get f dash x is equal to 2x plus a. Acha, today there will be class, okay? Mathematics class. Kind of like 5, no, not 5, 4, 4:30. Okay? 4:30 is okay. 4:30 is okay, right? Yeah. So now, this is f dash x we got. So after getting this f dash x, we have to find the corner points. So let us write 4 corner points. So 4 corner points. So 4 corner. No, sir, take at 3. 3. You have any idea at what time do I have lunch? I have lunch at 2:45. In here there is so many problems. I'm not at home right now. So for corner points, as I will try to take at 4 or 3:30 like that. So for corner points, f dash x equal to 0. F dash x equal to 0. So I will write 2x plus a is equal to 0. Right? So let us find the value of x. What is the corner point? So x is equal to what? Minus a by 2. So I get x as minus a by 2. Now listen very carefully. It says what? My function is increasing function, right? Yes or no? The function is increasing function. Yes or no? So if the function is increasing, my x value I got what? Minus a by 2, right? Am I clear? अरे किसी को समझ में नहीं आ रहा. X value we got what? Minus a by 2. Yes or no? This is the value of x. The corner point is minus a by 2 when the f dash x equal to 0, right? So now if the function is increasing, now do one thing, put minus a by 2 in here, put minus a by 2 in here, and you see what you get. If I put minus a by 2 in here, so I get 2 into minus a by 2 plus a, that is equal to what? Minus a plus a, that is 0, right? Yes or no? Now you see, you have to tell me the least value for which the function is increasing. The least value of a for which the function is increasing. Now least value of a means what? I have to tell a value of a such that this one is greater than 0. 2x plus a is greater than 0. Yes or no? Yes or no? Understood? So in order to write down in here, so I will write here x is, therefore the least value of a. So x is greater than minus a by 2 for the least value. Acha, another thing, x is greater than minus a by 2. So look at here. The points are what? Between 1 by 2, right? So between 1 to 2, there are so many x values. Can you tell me what is the lowest x value between 1 to 2? What is the lowest x value between 1 to 2? These are all x values, yes or no? These are points, yes or no? So x is 1, x is 1.2. So x is 1 is the least value? Yes or no? X is equal to 1 is the least value, right? So write down. So for the least value, 1 is equal to minus a by 2. That implies therefore a is equal to minus 2. Everyone clear? Yes or no? The least value of x is what? 1, right? The least value of x is 1. So I will just put in this expression, I will put 1 is equal to minus a by 2. So that gives you the answer of a. Now let's move on to the next question. Achha, this thing you don't have to write. This thing you don't have to write. Forget about it. This thing you don't have to write. You just have to write x is equal to minus a by 2. Then for the least value, you write like 6. You write x is equal to 1 for the least value. Now let's move on to the next question. This question is important. Okay. Now let's move on to question number 15. So question number 15 is what? Let I be an interval minus 1 to 1. Prove that the function given by this thing is strictly increasing on I. Chalo, ye karte hain. So they have told you that in that question, let I be an interval disjoint from minus 1 to 1. So what do they mean? What do they mean? I is equal to interval disjoint. Disjoint from minus 1 to 1. Can anybody tell me what does they mean? I is an interval disjoint from 1 minus 1 to 1. What do you mean by disjoint sets? What do you mean by disjoint sets? You have done before in class 11. Disjoint sets are what? The two sets which have nothing in common, right? Huh? Two sets which have nothing in common are known as, yes, intersection is 0. Two sets which have nothing in common are known as disjoint sets. So here interval disjoint from minus 1 to 1, it means what? Suppose I have a number line. Suppose I have a number line. It's from infinity to minus infinity, and this interval is what? Minus 1 to 1. So I will mark minus 1 to 1. So the interval disjoint from minus 1 to 1 means what? It means this interval union this interval. So basically they are talking about minus infinity comma minus 1 union 1 to infinity. They are talking about this interval. That's what disjoint of minus 1 to 1 means. Okay, clear? So this one has nothing in common with this one, so that's why they are disjoint sets. Acha, now what they have asked you to prove that the function f given by x plus 1 by x is strictly increasing on I. So we have to prove that in this interval I the function is increasing. So basically we have to prove that the function is increasing in this region and increasing in this region. Okay, understood? Yes or no? So we have to prove this thing. They are strictly increasing on I, and I is, this interval is I. So let us find this one. Let us do this one fast. So first thing what I will write the function. What is my function here? So fx is equal to x plus 1 by x. So first thing what I will do, differentiate. So differentiating with respect to x, I get f dash x, f dash x is equal to differentiation of x is 1. And differentiation of 1 by x is what? It is minus 1 by x square. We need to remember these differentiation formulas. So this is the differentiation of fx we got. Now after getting this one, we will do what? Find critical points. So for critical points, what I will do is f dash x equal to 0. Achha, here I can simplify this one further. So if I take LCM x square minus 1 divided by x square. Okay. So this is what we got. Now let's simplify now. So I get x square minus 1 divided by x square is equal to 0. This x square can never be 0. If this x square becomes 0, then the whole process will become undefined. So x square cannot be 0. So I will write x square minus 1 equal to 0. X square minus 1 equal to 0. Or we can write what? X minus 1, x plus 1 equal to 0. So from here what we have? Either x is equal to 1, either x equal to 1 or x equal to minus 1. So these two values we got, right? And after getting these values, what I will do? I will do the number line. So let us draw the number line. Let us draw the number line. So on the number line, we have what here? Infinity, and here we have minus infinity. So the two critical points are 1 and minus 1, right? Let us plot them in here. So I have 1 in here and I have minus 1 in here. Now, so again, this number line has been divided into three parts by these critical points. So first part, second part, and third part. Okay. Now tell me one thing. Just now we will discuss about the first part. So in the first part, I have all the values in the right hand side of 1. So tell me a value more than 1. Tell me a value more than 1. 2. Yes or no? If I have to take a value more than 1, that is 2. Now, do one thing. Now, put that value 2 in here and tell me will it be positive or not. Put that value 2 in there and tell me will it be positive or not. Come on, guys. It will be positive or not. Don't say yes, sir. It will be positive, right? 2 square minus 1 divided by 2 square. So it will be 3 by 4. So I will write here f dash x greater than 0. It is positive, that's why slope is greater than 0. Now tell me a number between minus 1 to 1. Tell me a number between minus 1 to 1. Tell me a number between minus 1 to 1. We cannot take 0 because if you put 0 in here, it will become undefined. Take another number. Take another number. Acha, let us take minus 1 to it's the point. Minus 1 is a critical point. I cannot take minus 1. If you put minus 1 here, that will become 0. So let us take half. Let us take half in there. So if I take half in there, so what we have? So half square minus 1 divided by half square. So you see what you get? You see the value is what? Half square is what? 1 by 4. 1 by 4 minus 1 divided by 1 by 4. And I don't care about the denominator. Look, 1 by 4 minus 1 is what? A negative number. So I will get a negative number if I take a value between minus 1 to 1. So here the slope will be f dash x is less than 0. So the slope will be less than 0. Now the last one. Take a value less than minus 1. Now, if I have to take a value less than minus 1, what it will be? It will be minus 2. So, put minus 2 in there and tell me whether it's positive or negative. Put minus 2 in here and tell me is it positive or negative? Guys, come on. So, if I put minus 2 in here, minus 2 whole square is 4. 4 minus 1 is 3. And denominator also minus 2 whole square is 4. So, again I get 3 by 4. So, again this side is positive. So, here I will write what? F dash x is greater than 0. Okay, so both of them, so you see between minus infinity to minus 1 it's positive, and between 1 to infinity it is also positive. Okay, so write down. in the interval in the interval minus infinity to 1, sorry, minus infinity to minus 1. Let me write here properly. In the interval minus infinity to minus 1, f dash x is greater than 0. So the function is strictly increasing in minus infinity to minus 1. And then write in the interval, what is that? We move on to the next page. Wait a second. So in the interval, we get what? 1 to infinity. 1 to infinity, f dash x is greater than 0. So the function is strictly increasing in 1 to infinity. So these two intervals, we see that the function is strictly increasing. And then what I'm going to write? Now, I is equal to, what is I equal to? We already found out. It is minus infinity comma minus 1 union, sorry, the bracket is wrong in here, minus 1 union 1 comma infinity. We have already discussed why the interval is like this. So what we can see is that the function is increasing in here minus infinity to minus 1, and the function is increasing in 1 to infinity, right? So combining those two, so we can say that the function is increasing in both these intervals. Hence hence the function fx is strictly increasing in the interval I. So hence we can say that the function is strictly increasing in the interval I. Okay, so that's how we